Okay, so let's do another example. So this is an example to get us used to the notion of constraints. So consider a box without a top. Or if you like, we're going to find the box without a top with least surface area for a fixed volume. All right? Find the box without a top with least surface area for a fixed volume. The procedure for working this out is the following. You make this diagram and you set up the variables. Right? In this case, we're going to have 4 names of variables. All right? We have 4 letters that we have to choose, and we'll choose them in a kind of a standard way. All right? So first, I have to tell you one more thing, which is something that we could calculate separately, but I'm just going to give it to you in advance, which is that it turns out that the best box has a square bottom. And that's going to get rid of one of our variables for us. So it's got a square bottom, and so let's draw a picture of it. So here's our box. Well, I guess that goes down like this. Almost. Maybe I should get it a little farther down. All right. All right, so here's our box. Let's correct that just a bit. All right, so now what about the dimensions of this box? Well, this is going to be x, and this is very foreshortened, but it's also x. The bottom is x by x. It's the same dimensions. And then the vertical dimension is y. Okay? So far, so good. Now I promised you 2 more letter names. I want to compute the volume. All right? The volume is, the base is x squared, and the height is y, so there's the volume. And then the area is the area of the bottom, which is x squared. That's the bottom. And then there are the 4 sides. And the 4 sides are rectangles of dimensions xy, so it's 4xy. All right, so these are the sides. And remember, there's no top. So that's our setup. So now, the difference between this problem and the last problem is that there are 2 variables floating around, namely x and y, which are not determined. But there's what's called a constraint here. Namely, we've fixed the relationship between x and y. And so that means that we can solve for y in terms of x. So y is equal to v divided by x squared. And then we can plug that into the formula for a. So here we have a, which is x squared plus 4x times v over x squared.